Kepler's first law of planetary motion states that all the planets revolve around the Sun in elliptical orbits, with Sun located at one of the foci of that particular elliptical orbit. So, considering the Earth itself, Earth goes around Sun in an elliptical orbit with Sun located at one of the foci, which means that if this is the ellipse, major axis, minor axis, right? Then ellipse has two foci, F1 and F2. Now how do you understand the foci? Suppose this is a paper and I put two nails over here and I insert a thread, put a stylus or a pencil over here, and I move the pencil in such a way that this thread, all the three sides of the thread are stretched or are in tension all the time. What will be described is an ellipse. That means the total of the distance from the two foci is constant. That means ellipse is locus of a point maintaining a total distance from two fixed point constants. That means while the Earth goes around the Sun in an orbit, the distance from the two foci, the total of the distance from the two foci is constant. That is what is the ellipse. So now, having understood what is ellipse, what is minor and major axis, let us now think on the first law that Mr. Kepler has given, and that is Earth goes round the Sun in her orbit that is elliptical, and Sun is located at one of the foci. If that is true, then this position, while the Sun is closest, the Sun's diameter should appear largest, and this position, while the Sun is furthest, the diameter should appear minimum. In fact, this position happens on 1st of January. It is called perihelion, and this happens on the 4th of July. It's called aphelion. The distances as well as the semidiameter as seen from the Earth would vary. In fact, on the 1st January, the distance is 91.35 million miles, and the semidiameter that would appear from the Earth would be 16.3 minutes. Whereas aphelion, which happens on 4th July, will give you a diameter, semidiameter 15.8 and distance 94.45 million miles. That kind of variation of distance happens on perihelion versus aphelion. All the planets revolve around the Sun in elliptical orbit with Sun located at one of the respective ellipses foci. The Kepler's second law now is also interesting, and it says that the radius vector sweeps equal area in equal time. Once again, Sun at one of the foci. It means that as the Earth moves here, the radius vector in a given time, suppose, sweeps this area. Over here, the area swept would be equal if the time interval is same. If this time interval and this time interval is same, the area swept would be equal which means that the linear speed over here would be more than the linear speed over here. This is Kepler's second law. Now, how do we believe that this law is also correct? And what would be the implication? The implications are evident, and the result is the solar day. Solar day means, suppose we are talking about one day from here to here. Solar day means while this observer has sun on meridian, next when the same observer finds the sun on meridian is the interval of one solar day. Now, this is also solar day and this is also solar day. You can see that the earth has traveled extra distance here. So length of solar day would be more over here and less over here. And because of earth going at varying speed in her elliptical orbit, the relative motion of that being the sun going on ecliptic in sun's eastward annual journey, sun would move on ecliptic at varying speed. And the effect of that is variation in length of seasons. That is one of the factors which is responsible for different lengths of seasons.